We're up to problem 19 now. Hopefully you can read this. It's pretty small print, but so the instructions say, use a coterminal angle to find the exact value of the following expression. Do not use a calculator. And there are two boxes. The first box, they want to know the coterminal angle. And then the second box. So really what they're really wanting to know is, what is the sine of a 780 degree angle? But the way we're going to determine this is by using a coterminal angle. Now, since they asked for the exact value, I have to assume that this is a special angle. But let me explain this. 780 degrees is not found on the unit circle. All the way around the unit circle goes to 360. So as of now, I cannot find a 780 degree angle on the unit circle. But of course, what happens is, if you go all the way around, it's 360. And then if you keep going around, you need to keep going around the unit circle until you get to 780. So the first thing I'm going to do is I'm going to find a coterminal angle. Coterminal angles are two angles that have a different measure, but they start and stop at the same place. So here's how you find a coterminal angle. I need to reduce this angle until I get it inside the unit circle. So since all the way around the unit circle is 360 degrees, I'm going to subtract. Whoops. 420 degrees. Of course, 420 degrees is still not inside the unit circle. So here's what this is saying. Let me actually sort of diagram it on this first problem so you know what you're doing. They're asking for the trig function of a 780 degree angle. So we start here, we go all the way around at this point. We've gone 360 degrees. If I go around again at this point, I've gone 720 degrees. Now, how much further do I have to go to get to 780 degrees? I need to go 60 degrees, which is about here. So this is a 60 degrees. So this angle here is my 780 degree angle, or the coterminal angle is 60 degrees. Coterminal angles start and stop at the same place. For a 780 degree angle, I start here. I'll say I start here. I go 360, 720, 780. I stop here. For a 60 degree angle, I start here and I stop here. Now, why this is important is because the trig functions of two coterminal angles are the same. So when I began this problem, I was trying to find the sine of 780. I don't know what it is because it's not on the unit circle. However, because of coterminal angles, I've decided the sine of 780 is the same as the sine of 60. And I know what the sine of 60 degrees is. Square root of 3 over 2. So I look at the questions for this problem. The first thing they ask is, what's the coterminal angle? And we found it was 60 degrees. And the next question is, so what's the sine of 780 degrees? Well, it's actually the same thing as the sine of 60 degrees. So the exact answer is square root of 3 over 2. So that's all these problems are going to be. You're going to start out with an angle that's not in the unit circle. So you need to start reducing that angle and find the coterminal angle within the unit circle, and then you can find the trig function. So with these degree problems, for this one, 765, you start subtracting 360 degrees, because that's how far it takes to get around the unit circle. So when you subtract 360 degrees, you're left with 405 degrees. I'll subtract 360 more degrees, and you're left with 45 degrees. So the coterminal angle of this 765 degree angle is actually 45 degrees. So the tangent of 765 is the same thing as the tangent of 45 degrees, and we know that the tangent of 45 degrees is just 1. So that's how these kinds of problems work. So just to have practice, they gave you a few more. Now here's one with a little twist. The cosecant of 1035 degrees. First thing I do, because it's a cosecant, I don't like to work with cosecants. Cosecants is paired with sine. What I'm going to do is I'm going to say, I know that the cosecant of the negative 1035 degree angle is 1 over the sine of 1035 degrees. So what I'm going to do is I'm going to go off and now figure out what the sine of a negative 1035 degrees is. Then I'll plug that back in here in the bottom of the fraction, and then I can finally get. So now we first need to find the coterminal angle of negative 1035. So the little twist is, since this is a negative angle, if I want to get this inside the unit circle for a negative angle, well, I can really do one of two things. I can look for an angle between, well, actually, I think by definition, now that I think about it, a coterminal angle should be a positive angle. So in this case, I need to keep adding 360 degrees until I get a positive angle in my unit circle. So just to save time, 360 plus 367, let's start out with 720. So 1035 degrees plus 720. Now 720 to 1000 is 280. I did this in my head. Hopefully it's correct. However, I still have a negative angle, so let's add 360 more. And finally, I get a positive angle of 45 degrees. So that is my coterminal angle, which means a negative 1035 degree angle is coterminal with a 45 degree angle, which means the trig functions are the same. So now 1 over the sine of 45 degrees, which is 1 over, if I go to my unit circle, the sine of 45 degrees is square root of 2 over 2. If I simplify this complex fraction, now just so you know, it's not really required in trig, but someone might like to rationalize this. Get rid of the square root in the bottom. Multiply top and bottom by square root of 2. and you get 2 square root of 2 over 2, which is the square root of 2. So I'll just put an answer of square root of 2 in here. Although I'm pretty sure in WebAssign, if you enter 2 over square root of 2, I think it will also count that as correct. All right, so that had a couple of twists to it. Let's see what the next problem is. I think we have a few more of these. Okay, now we switch to angles and radians. Might be a little trickier because now we're having to work with some fractions. So just interesting, right away we jump off with a cosine of negative 23 over 3. And because they asked for an exact value, I'm confident that at some point the coterminal angle is going to be on the unit circle. So with radians, all the way around the unit circle is 2 pi, so that's what I have to either add or subtract to try and reduce this. Now, since this is a negative angle, I really need to take negative 23 pi over 3 plus 2 pi. I need to keep adding 2 pi to this until I get a positive angle inside the unit circle. Of course, I can't add these in the current form. I need to get a common denominator. So 2 pi is the same thing as 6 pi over 3. So really what I have is, so these are going to be coterminal angles. Sorry, negative 23. So that's like negative 17 pi over 3. So I need to add another 2 pi. I get negative 11 pi over 3. If I add another 2 pi, I get negative 5 pi over 3. And if I finally add another 2 pi, I finally get a positive angle. So the coterminal angle of negative 23 pi over 3 is pi over 3. So the cosine of negative 23 pi over 3 is the same thing as the cosine of pi over 3. Cosine of pi over 3 is 1/2. Here's another one. What is the tangent of negative 5 pi? So let's go find the coterminal angle of negative 5 pi. Now this should be easier than the last one because I don't have to do all the fractions. So negative 5 pi plus 2 pi is negative 3 pi. If I add 2 more pi, I get negative pi. And if I add 2 more pi, I get pi. So negative 5 pi and pi are coterminal angles. So now the tangent of pi is, if you go to the unit circle, pi is over here. Tangent is always the sine over the cosine. So the sine is 0, cosine is negative 1, and the tangent is going to be 0. So the tangent of negative 5 pi is 0. All right, a few more. I just want you to get lots of practice on these. How about the secant of 9 pi over 4? I can get rid of the secant by basically saying, let's make it 1 over the cosine of 9 pi over 4. Now if I can find the cosine of 9 pi over 4, then I can get my answer. 9 pi over 4 is not in the unit circle. So I'm going to subtract 2 pi, but with the denominator 4, subtracting 2 pi is subtracting 8 pi over 4, which is pi over 4. So 9 pi over 4 and pi over 4 are coterminal angles. So now the cosine of 9 pi over 4 is the same thing as the cosine of pi over 4, square root of 2 over 2. However, now this goes in the bottom of this fraction. Now we just had the same problem a few minutes ago, and when I simplified it, this ended up being just the square root of 2. Oh, you notice here, they didn't ask for the coterminal angle this time. They just asked for the answer. So I wasn't paying attention. So there's just one answer box, so you would put in square root of 2. Here, they want another tangent of 5 pi. Well, we're going to use a coterminal angle. So in this case, we're going to start subtracting 2 pi until we get inside the unit circle. So if I subtract 2 pi, I get to 3 pi. If I subtract 2 more pi, I get to pi. So 5 pi and pi are coterminal angles. So really what this says is, the tangent of 5 pi is the same thing as the tangent of pi. And the tangent of pi, we just looked at a few minutes ago. Tangent of pi is over here. Sine over cosine 0 divided by -1 is 0. Secant of -2 pi, first thing I'm going to do is going to change it to 1 over the cosine of -2 pi. Now let's go find the coterminal angle for -2 pi. If I add 2 pi, you get 0. So 0 and -2 pi are coterminal angles. So really, cosine -2 pi is the cosine of 0, which is 1. So you put a 1 in here for cosine of -2 pi, you have 1 over 1, which is 1. So the answer for 26 should be 1. All right. Hopefully you get the hang of those problems and they're not too bad. Let's go and do these next problems. Aren't too difficult. I think there's 2, 4 of them. Maybe I'll even zoom in so we can make sure you can read it. So this problem says, name the quadrant in which the angle theta lies. So then it gives us 2 pieces of information about theta. It says the sine of theta is greater than 0 and the cosine of theta is less than 0. We want to know which quadrant theta is in, right? We have 4 quadrants. Let's first look. Here's how you do these. You look at the sine of theta greater than 0. Greater than 0 means positive. So for which quadrants is the sign positive? Think of the sign is like y. So these 4 quadrants, what are the quadrants where the sign or where y is positive? Well, obviously, quadrant 1 and 2. So according to this first inequality, I've now figured out that theta has to be either in quadrant 1 or quadrant 2. But of course, the question says which quadrant. So which one should it be, 1 or 2? Well, that's why they give us the second piece of information. So say theta, so at the same time sine of theta is positive, cosine of theta is negative. Cosine of theta less than 0. Of the 4 quadrants, where is the cosine of theta negative? Where's the cosine negative? Well, cosine is like x. So for which quadrants is x negative? Well, 2 and 3. And then what you do is you have 2 quadrants for sine, excuse me, 2 quadrants for cosine. You see which quadrant they have in common. Quadrant 2 works for both of those, therefore this angle has to be in quadrant 2, and you would just circle in that. So these are actually pretty straightforward. We'll just finish these other 3. Sine of theta less than 0. Which of the quadrants where the sine is less than 0? Well, the sine is like y, so we're saying where is it negative? It's negative in 3 and 4. And then the cosine of theta greater than 0, cosine positive. Where's the cosine positive? Well, that's like where's the x positive? X is positive in 1 and 4. So what quadrant they have in common? Looks like quadrant 4. This next one, sine of theta less than 0, which means sine of theta negative. Where's the sine of theta negative? Sine's like y, so it's 3 and 4. And then tangent is less than 0. Where's the tangent negative? That's a little tricky because you have to remember that tangent is sine over cosine. So if we want this to be negative, well, when you divide 2 things and you want the answer to be negative, that only happens if one of these is positive and one of these is negative. So which quadrants in the unit circle are the sine and cosine opposite, where one of them is positive, one of them is negative? Well, not quadrant 1, because quadrant 1, they're both positive. Quadrant 2, sine's positive, cosine's negative, so it can be quadrant 2. How about quadrant 3? Sine and cosine are both negative, so when you divide them, it ends up being positive, so that's not good. But quadrant 4, cosine's positive, sine's negative. If you divide them, you get a negative number, so it looks like for tangent of theta less than 0, that occurs in quadrants 2 and 4. Which one's in common? Quadrant 4. And the last one, cosine theta greater than 0, cosine theta positive. That occurs in quadrants 1 and 4. Tangent's positive. That means that's where the cosine and sine are the same, either both positive or both negative. That happens in quadrants 1 and quadrants 3. What's the common quadrant here? Quadrant 1. All right, let's stop there and we will pick this up in the next video.